all SUNY Oneonta students, you're going to take a sample, but you don't want your sample to be so that all students in the sample are philosophy majors, or all students in the sample are physics majors, or all students in the sample are seniors, or all of them are juniors, that kind of thing. You want it to be representative of the entire population. We also have this notion of a statistic. This is just a value that's calculated using all the sample data. So parameter is for the population, statistic is for the sample. So that's what's happening here. Now, how do we actually make such a sample? How many people do we include in the sample? People or objects, I should say. That's not obvious. There are different methods to form a sample. But the whole point is, this is what I was saying before. So it's on the slide here, so I'm not going to say it again. You want it to be representative of the entire population. Okay. So, and this is just another example that was actually in the book. I just wanted to bring it up. For instance, if you wanted to get the average length of all the trout in a certain lake, so what researchers might do is they'll catch 20 of the fish in the lake, measure them, right? So what would the population in the sample be? Well, in this case, the population would be all the trout in the lake, and the sample would be the 20 of them that they catch. It's just an example I just wanted to do quickly. Okay? All right. And this is just another example. Like, suppose the college reports that the average age here for SUNY, for their students actually, is 28 years old. So would that be a statistic or parameter? Well, odds are that's going to be a parameter, mostly because it would make sense that the college has each of their registered students' age. That is something they get. So it would make sense to say it's a parameter. It deals with the whole population. Again, these are just some examples I'm just wanting to go through quickly. So, I like doing examples. So. Yeah. All right, so going back to this, what do you call it, this sampling, how exactly can you obtain a sample? How can you actually do that though? Once you know what the population is, how do you form a sample? Well, that can be tricky though, okay? Again, it has to be representative of the entire population, okay? It has to be representative of the entire population. You don't want the sample to just have seniors or only students that are majoring in humanities majors, right? You want to make sure it's representative of the entire population. Okay, so what kind of methods can we use? Well, there's different methods you can use. Oh, okay, not there yet. All right. Anyway, we have to be, and why are we careful when forming these samples? Mostly because you want to avoid sampling bias. That's why. You want to be careful in that you avoid sampling bias. Okay? All right. Basically, a sampling method that we'll see, it's said to be biased if some members of the population are more likely to be included than others. If some members of the population, they're more likely to be included than other methods, than other people, okay? Again, you want it to be representative of the population. So, for instance, here's an example. If you somehow were only going to include people that have a class in Fitzell, right? Well, that would have sampling bias because not everyone has their class in Fitzell, for instance, right? So people that have a class in Fitzell would be more likely to be included in our experiment, that kind of thing. Okay, so we want to make sure we don't have sampling bias, okay? All right, well, there are different methods we can use. One is to make a simple random sample. That's where every member of the population and every group has an equal probability of being chosen, okay? So again, that's where every member of the population and any group of members, they're all equally likely to be in the sample. So odds are this is really what you want. There is a difference between a simple random sample and a random sample. I actually wrote it here from this website. Okay. All right. So it is a little bit different. I mean, they say here from the website that a random sample, not every object has an equal chance of being chosen. So it is similar to a simple random sample. So I just wanted to point that out. So, I mean, how do you actually get a simple random sample? I mean, it's one of those things where theoretically it's easy, but it's very hard to implement though. So practically it's very hard to do, but theoretically it's very simple to do. Okay. So that's what we have here. So that's what a simple random sample is. All right. Also, with these samples, whenever you have a sample, there's always going to be some kind of variability. I mean, for instance, let's say we were choosing a sample of 1,000 students, right? Well, if we were to keep choosing samples of 1,000 students each, right? So if we were to repeat the experiment to see what kind of data we get, and we choose different samples of size 1,000, even if it is representative of the population each time, there's still going to be some variability because there's going to be different people in there. You know, some samples, for instance, might have more seniors than other samples, or some samples might have more freshmen than other samples, that kind of thing. So there is some kind of variability here. Okay? So that is normal. I mean, it's unavoidable, but you can get around it by making your sample larger, though. Not get around it, I shouldn't say that. You can minimize it by making it larger. That's what you can do. Okay? Good. So that's what you can do here. Okay. So here is a method of sampling. Let me get to that. Okay. Oh, sorry,